Just like the previous sections, we want to build a tree from scratch, so we better understand how these trees work internally. So as an exercise, I want you to create a tree class. In this class, we're going to have a bunch of nodes. So node is going to be a private class inside the tree class, just like the node class that we had in linked lists. In linked lists, our node had two fields, value and next, which is a reference to the next node in the list. Now in doubly linked lists, our nodes also had the previous field. But in trees, we're not going to have next and previous. We're going to have left child and right child. So with this structure, we can model a tree like this. Each node has a value as well as a reference to its left and right child. Okay? Now this tree class itself should have a root field, and this is a node object. Again, very similar to linked lists. Now in this class, I want you to implement two operations. One is insert, which takes a value. And for now, let's just assume all these values are integers. The other operation is find, which takes a value and returns a Boolean. So we just want to see if we have this value in our tree or not. Now, what about the delete operation? We're not going to implement that because deleting a node from a binary tree is fairly complex. It has a few edge cases, and honestly, it hardly comes in interviews. They don't ask you because it takes a lot of time to implement it. So I don't want you to get stuck implementing a tree with all these operations. Instead, we only want to implement insert and find operations, and then look at other algorithms around trees. These are the algorithms that come up in interviews quite often. Now, let me give you a hint before you get started. In both these operations, first you need to find a node. For example, when inserting a value, first we need to find where in the tree we should insert that value. Similarly, when we want to find that value, we need to use our lookup algorithm. So earlier I told you that to look up a value, we start from the root node. So we can declare a current variable and initially set it to the root. Now here we need a while loop. And in this loop, we want to compare the value of the current node with the value that we want to insert or find. If the value is smaller, we should go to the left subtree, right? So we set current to current.leftChild. Otherwise, if the value is greater, we go to the right subtree. We keep doing this until we find the target node. So go ahead and build this tree. It's probably going to take you about 20 minutes. It doesn't matter if it takes you longer. When you're done, come back, see my solution.